Hello, happy Thursday or Friday. Today we're going to be going through properties of exponents. So we're going to be in your student journal starting on page 168. And we're going to go through all of the different things that you need to know when working with exponents. So the goal for today is how can you write a general rule involving properties of exponents? So we're going to start off with some multiplication. So it says, what happens when you multiply two powers with the same base? Write the product of two powers as a single power. Then write a general rule for finding the product of two powers with the same base. So that has a lot of words and it has a lot of vocabulary in it. The big things to remember when we're dealing with exponents is we have something like this, a to the x. So the number that is a, so the big number in the problem, that's our base. And then the little tiny x, or whatever number that is our power, or our exponent. And so when we're dealing with exponents, the power, or the exponent, so the little tiny number, tells us how many times we multiply the base. So for example, when we're looking at 2 squared times 2 cubed, that's the same thing as saying 2 times 2, and then this one is 2 times 2 times 2. The 3 tells us that we have 3 2's, and the 2 tells us we have 2 2's. Now we can actually work through the multiplication. So 2 times 2 gives me 4, and then 2 times 2 times 2 gives me 8. So my answer here is 32. We're going to get to some shortcuts, and I want you to take note of anything that you notice while we're going through this. If you're like, oh, well, I could have just done this instead. Keep those thoughts at the top of your head because we are going to come back to that as we go throughout this. So let's look at the next one. We have 4 to the first power and 4 to the fifth power. So obviously 4 to the first is just 4. That's all it is. Now we have 4 to the fifth power, so that's 4 times 4 times 4 times 4. Oops, times 4. That's going to give me a really big number. So this is something that I even have to use a calculator for because that's going to give me a huge number. I mean, not huge, but definitely bigger than what my brain wants to do, and that's okay. I get 1,024. So looking at the last two, so looking at the first question did, and the second question we did, what do you notice? Okay, so we have a 2, we have a 3. Well, we had 1, 2, and then 3, 4, and 5. What's 2 plus 3? That's 5. Well, and we had 5 too, so this problem right here could have been written as 2 to the fifth power. And that would have saved us some time because then we could have just put that directly into the calculator instead of having to do separate problems with separate work. So in this next one, well, if we had 1 and 5, 1, 2, 3, 4, 5, 6. This could have been written as 4 to the sixth power. Try this next one on your own. So this obviously gives you a really big number. I don't expect you to be able to do this by hand. You can use a calculator, and that's what we get. But I saved some time by figuring out 5 to the 8th power, and then I was able to put that into my calculator. So we'll do this next one together since it's got some variables. So the same rule applies. We're going to take the exponents and we're going to add them together. So I get x to the 8th power. That's all you have to do on this one. There isn't anything else you can do. You don't know what x is, so that's it. So the general rule when you're adding is if you have the same base, let's do x to a. This is going to be the same thing as x to the a plus b, because we add those two numbers together, and that's how we can move forward. Now let's move on to division. So we're going to figure out what happens when we divide something with the same power, or with the same base. So we already know 4 to the 3rd power is just 4 times 4 times 4. And I'm just going to make this my fraction bar to make my life easy, over 4 times 4. So I can do this one of two ways. I can simplify, then multiply, or I can multiply, then simplify. I'm going to do both. So I'm just going to write the same problem down directly below. And we'll do it two different ways. I'll start by multiplying because I predict that's what a lot of people are going to do because that's what you're comfortable with, and that's okay. So 4 times 4 times 4 is 64. And 64 is the top part of my fraction, and then I have to take 4 times 4, which is 16. I can put that in a calculator, and I get 4. Now for the next one, I'm going to simplify. Whenever you have division and it looks like a fraction, you can easily reduce before you start working. You find commonalities. So I see that we have those two 4s in common and these ones in common. Since they have them in common, they simplify. Well, all I'm left with is 4. I got the same exact answer. I didn't have to really do much work. What do we notice between 3 and 2? And we end with 4 to the 1st power. Well, 3 minus 2 gives me 1. And that's how I get 4 to the 1st power as my answer. That's confusing? That's okay. Let's try it again. Now I have 2 to the 5th power over 2 to the 2nd power. So again, we have two ways we can do this. We have 2 times 2 times 2 times 2 over 2 times 2. So I'm going to multiply to start. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 is 32. And then it's all over 2 times 2, which is 4, and then that gives me 8. Well, let's go about it the other way. So 1, 2, 3, 4, 5. So again, the first thing I look for is those commonalities. So those ones cancel. And that cancels. So I'm left with 2 times 2 times 2, which is just 2 to the 3rd power, which is also equal to 8. Let's check and see if our theory from the last one works. So we're looking at our exponents. 5 minus 2 gives me 3. I get 2 to the 3rd power, which is what I had right there. Makes it a whole lot easier when we go about it that way, because then we really don't have to do much multiplication. All right, let's look at this next one. So this next one has letters. So remember, this is super easy. All we have to do is follow the rule. But we'll do multiplication. So I have that one, goes away. I have this one, it also goes away. Now I'm left with x times x times x, which is just x cubed. So if I follow my rule right here, if I take 6 minus 3, I get 3. So I would have gotten x to the third power, and I didn't even have to write it all out. Same answer, less time. All right, try this next one on your own, see what you can get. All right, if you're just joining back, you can see 4 minus 4 gives me 0. 3 to the 0 power equals 1. You could have also figured this out because it's the same thing divided by the same thing. Anything divided by itself is always equal to 1. And then anything that is ever taken to the power of 0 is also equal to 1. So for our general rule on this one, so if we have x to the a over x to the b, it's equal to x to the a minus b. I would make sure that you get these general rules written down because these are going to be really helpful as we move further into this section. Okay, now we're moving on to what happens when you find the power of a power. So this is when you have a number that has an exponent and you're taken to another exponent. It can get kind of tricky, but once you learn the general rule, this becomes so easy. Because this 4 right here tells me I have 4 of those 2 squareds. So it becomes 2 squared times 2 squared. Oops, wrong thing, sorry. So 2 squared times 2 squared times 2 squared. So now I have 4 of those. Well, now this goes back to our first rule because we're just multiplying here with the same base. We can add our exponents together. So 2 plus 2 plus 2 plus 2 gives me 8. So now I have 2 to the 8th power. Well, does anyone notice that correlation right here? 4 times 2 gives me 8. So then I would have 2 to the 8th power. So 2, 4, 8, 16, 32, 64, 128, and 256. Let's try this on the next one. So I'm going to try my rule. I'm going to take 2 times 3. So now I have 7 to the 6th power. And again, this is not one I expect you to know. Because it gives me 117,649. All right, let's go to the next one. So now we have an exponent, or we have some variables thrown in there. If we follow the rule, it's easy. So I take 3 times 3, so I get y to the 9th power. That's it. One step and you're done. Try this next one on your own. You should have gotten x to the 8th power because 4 times 2 gives you 8. So our general rule on this one. So if you have x to the power of a, all taken to the power of b, that's the same thing as x to the power of a times b. Alrighty, so now we have a few more. This is just another thing when you're finding, when you've got multiple things going on. So we can do this, we're going to do this 2 ways. We're going to start by doing what's in the parentheses first. So I have 2 times 5, that gives me 10, 10 squared gives me 100. That was pretty easy. The other way, which is going to be more helpful when we look at the question below, like this one, is we have to use our distributive property. We're going to take our exponent and share it with everything that is on the inside of our parentheses. And I'm going to show you we get the same exact answer. So we get 2 squared times 5 squared. 2 squared is 4, 5 squared is 25, which also gives me 100. Yes, I know this first way was much easier, but if you look at number 3, that's not going to be possible because we don't know what a is. So let's look at the next one. So I'm going to distribute that 3 to everything on the inside. So I get 5 cubed times 4 cubed. It's 125 times 64. Again, use a calculator. I am. No shame in the game. And I get 8,000. See if you can try the other way. I don't know about you, but the other way was much easier on this one. But again, I'm only having you do it this first way because of the next 2 questions. Because we don't know what a is. We have to use the distributive property. There's no way around it. So I have to take 6 squared times a squared. Well, 6 squared is 36. A squared is just that. And that's your answer. We have to share the exponent with everything on the inside of the parentheses, otherwise we didn't fully answer the question. See if you can try this next one on your own. So there you have it. You should have gotten 9x squared distributed the 2 to everything on the inside, and that's how we get our answer. So our general rule, we have a times b taken to the power of x. It's the same thing as a to the x times b to the x. All right, last section. I know there's a lot going on in this one, but once you have these rules down, it's going to make your life so much easier, I promise. So we have to take 2/3 to the power of 2. So that means we have 2 of them. So 2/3 times 2/3. Well, if we're following our exponent rules, this could also be written as 2 squared over 3 squared. So what did we do? We took this exponent and we shared it with both of the numbers. So we get 4 over 9. Let's try the next one. So I'm going to take the 3 and it goes to everything. So I get 4 cubed over 3 cubed. 4 cubed is going to give me 64. 3 cubed is 27. And you don't need to rewrite these as proper fractions. Just leave them as an improper one. Totally okay. All right, try the next one. See if you can do it. I believe in you. I think you can do it. You're just joining back. You would have gotten x cubed over 8 as your answer because you can't do anything else with the x. All right, last one. Try this one. This one should be easy peasy. A to the 4th power over b to the 4th power. There you have it. So the general rule is if you have a over b and it's all taken to the power of x, it's the same thing as a to the x over b to the x.